So we're going to talk a bit about nets, and Dr. Kalcsits will present some very good information on the way that Washington growers use nets in order to improve quality.
All right, so this is talking a little bit more about what I've been doing for about 8 years, well, since I started at Washington State University. This is a big part of my program. I believe you've heard a little bit about this in 2018. You would have had a presentation on what we're doing in Washington State. We've had several ongoing projects since then, which I'll share. And I'll kind of just rehash some of the historical knowledge and what we found. You've probably already heard some of that. And then go into some of the new exciting things that we're doing in Washington State to optimize fruit quality underneath nets. So the main, as you know, the main reason why to use nets is hail and sunburn. It's very similar in Washington as it is here. The primary is sunburn, the secondary is hail. Other parts of the world, it's primary hail, secondary maybe sunburn. So we share very similar climates in terms of our summer sunburn pressure. It's very effective at reducing hail damage. A lot of the material is quite durable, lasts a long time, 7 to 10 years. We've had netting that has been an over-the-top structure that gets retracted in wintertime that is going on 9 years now, and still is very, very strong, not a lot of tears in it. So it's meant to be a durable product. There are products out there that are less durable than others, but in general, all the material out there is pretty good. So just to kind of hash out, what sunburn is and how it happens. So the thresholds for sunburn, there's different types of sunburn. There's sunburn browning, which is probably what you see a lot of here, like we do in Washington. There's photooxidative sunburn, which is very sudden exposure to light that the fruit is not adapted to. So it's very sudden, happens when fruit grows and the branch gets exposed, or during summer pruning. So there's been some discussion about summer pruning this morning and the importance of that for fruit color, but you need to counterbalance that out with the risk of photooxidative sunburn if you have warm temperatures or high light conditions after that summer pruning. And then the last is necrosis. You see that at the top. You see it under very high temperature conditions. So when the fruit surface temperature reaches about 52 degrees Celsius, which are days when the air temperature is roughly around 40. So those days that are 38 to 40 are really high risk times for apple sunburn and necrotic sunburn, which can happen at all times of the season. So in Washington, historically, we have managed sunburn through evaporative cooling. So that's the use of water over top of the orchard to, you wet it, you allow it to dry, you get the cooling effect from it evaporating off the fruit surface of the apple, and that provides that cooling effect that helps us control sunburn. We have, there's reflective sprays and protective sprays as well. They're not really full solutions to sunburn control. So really we're looking at evaporative cooling or netting. So in the last 7 to 8 years, netting has been more rapidly adopted, specifically for varieties where growers are trying to improve fruit finish. So evaporative cooling can affect fruit finish, can lead to excess vigor in your tree, and it reduces or eliminates your ability to control water. So if you're trying to control irrigation for horticulture or fruit quality purposes, say to reduce disorders or control vigor, by using evaporative cooling, you lose that effect. And then it also is very inefficient in water use, and in some years we have issues with water limitations, not to the extent of here, but it does happen. So when you talk about nets, there's different colors, there's different fabric weaves and how they do it. There are different shade percentages, so being 10% or 15 or 20% shade relative to full sunlight. So you can get different types of material out there, and they all affect the environment a little bit differently, but really the main effect is that net and that percentage that you reduce the incoming sunlight. So a 20% net, whether it's red or it's blue or it's white or it's gray or it's green, is going to reduce light by 20%. And the main effect of that is going to be just that reduction in incoming radiation that's hitting the fruit surface. I think, you know, you have like a fine tune and a rough tune knob sometimes on instruments. So the rough tune is the net. That's your benefit. The fine tune is the color more so, or the weave, or the, you know, whether it's semi-transparent. So there's little things you could do, but that main effect really is just getting net over your block and doing it in a controlled way where you understand that shade percent. So when I talk about what it does to the environment, it doesn't really change the temperature underneath nets. It decreases the incoming radiation reaching this fruit surface. So when you go out in open sun, you feel the sun on your skin, and that it feels hot to touch. So you go underneath nets, the air temperature isn't any different, but you feel that it's cooler because there's less radiation reaching the surface. And the apples feel that the exact same way. One of the other big benefits that growers are using nets for is reducing wind speed. So we see about a 40% reduction in wind speed. I see it very commonly used in cherries as well. They'll sometimes put it up on the sides. It doesn't have to be just a side enclosure and a top enclosure. Just having a top enclosure alone still reduces wind speed. It still reduces the mixing over top of the orchard. So you're still getting that benefit of wind speed even without those sidewalls on. So you don't need them to get that benefit of reducing wind speed. Another thing that netting will generally do, some nets, like the black net, won't do light scattering, but a lot of nets will scatter light. And when I talk about scattering light, when you go out into the orchard and you look down at your shadow in a really sunny, clear day, it's really strong. You know, you have a really dark shadow and really sunny beside you. But if you go into an orchard where there's nets over top and you look at your shadow, it's weaker. It's because there's light scattering in lots of different directions. It comes in and it scatters out. So you get better light penetration into the canopy. Better light penetration means better color, better flower induction, and just better tree health. Not getting all that light coming into the exposed parts. It's scattering throughout. And I think, you know, in areas like New Zealand where they get more cloud cover, it's closer to the ocean, they have better light scattering than more inland areas like areas like here. And in Washington State, we get very direct light. So anything that improves light scattering helps. Just showing just a real quick, obvious benefit is the reduction in sunburn. So this is 1 year of data, but we have lots of years of data of what it does to reduce sunburn. So in Washington, no nets. So the clean is blue. Y1 is still a high pack out. It's minor sunburn. Still would pack out a high quality fruit, like what you call a class 1 fruit. Y2, Y3, those are downgrades or culls, and then 10 is definitely a cull. So you can see no netting, only 50% of the fruit has no sunburn. When you add netting, it goes up to about 80% of the fruit has no sunburn. But more than 90% would be considered a class 1 in terms of grading out at sunburn, whereas only about 70% for no netting. So you see the very obvious benefit of netting in reducing sunburn. We see increases in fruit size underneath nets. So by reducing the amount of incoming radiation, by decreasing the stress on the tree, we're improving fruit growth. And this is Honeycrisp, so that's why you can see the fruit size is so large. 250 to 400 grams is fairly normal for Honeycrisp fruit, but we get about a 10% increase in fruit size for fruit underneath nets. I think one of the issues with nets is the color development, and there's negative consequences, especially if you're using a gray net or a black net, but even white net, there's still going to be a color penalty for using that net, and that's something that you need to be aware of. Some years it's worse than others, but in general you do get a small amount of color, but it's usually offset by that reduction in sunburn, the improved fruit finish, and the general improved fruit quality underneath nets. But color being one of the key metrics for packouts, it's really something that needs to be taken into consideration. So we did some work in 2018, 2019, looking at different shade percentages, because we're trying to find out, well, what's the optimum shade percent for reducing sunburn in both Honeycrisp and Granny Smith. So Honeycrisp being a bicolor variety and Granny Smith being Granny Smith. What we found was, so the black is completely clean fruit, and then you get increasing severity as you go up the graph into the different categories. And what you see is for Honeycrisp, 10% was perfectly fine for reducing sunburn. It was no different than 17 or 24%. So to optimize the red color, we could go somewhere between 10 and 17% for our shade and be okay. But for Granny Smith, what we see is that there is 10% is not enough. So we see an increase in sunburn losses for when we use 10% that is higher than 17 and 24%. But because color doesn't matter, we could push that higher. Going 17 to 24% is just perfectly fine for Granny Smith, because we're not worried about color. So shade percent matters in terms of reducing sunburn, and there is an optimum, but you have to balance that out with color development. We've also done some work with looking at reflective fabrics underneath the nets, and we used 2 different products and compared it to no reflective at all, and this was under a 20% net. So Extende is the white fabric material, and Mylar is the plastic mirror-like material. So it's got a mirror-like film on it, and we saw basically the same effect. We saw a strong improvement in red color underneath nets, and that level of red color underneath nets was about the same as what a non-netted tree would have developed color. So it pretty much counteracts that negative effect of netting. You know, it's not as good as just reflective material outside of nets, but it basically balances that out. Vili was talking about cons. You know, you rotate your reflective material. You have it in an early season variety, then you move it to a late season variety, and the more things you can use it for, the better it is. So we actually did some experiments in Granny Smith, looking at netting early in the season to improve light penetration into the lower parts of the canopy during flower induction. And so we put nets out 6 weeks after bloom time and left it for 6 weeks. So it was out during that flower induction season period for the next season. And we found that by doing that, we're able to reduce the off-year down cycle. So we're able to increase the amount of flowers in the lower part of the canopy from reflecting light up into that. So it's another use of reflective material at a time when you wouldn't normally use it. So just another tool in the toolbox. And another thing, so we just finished 1 year of this project, is to look at retracting nets just before harvest. So there's been a push to go to nets that can move very quickly back and forth. You know, you could do a hectare with one person in an hour or 2. So you're not up on lifts trying to stitch things together and manage the nets that way. So you can move them very quickly on the ground. This is just our research setup, but generally you'd have an over the top that would go over about 3 or 4 rows that would be clipped onto a cable that then can slide back and forth. So it's like a horizontal panel instead of going down the row. And the idea is that we can get the sunburn protection for the whole summer and then open it up as long as the weather's good to improve red color. So we tested retracting netting 14 days before harvest and 7 days before harvest. And this was for Honeycrisp, which is an earlier season variety. It picks about 2 weeks after Gala. So it is still hot during that time because we wanted to explore the trade-offs between red color and sunburn. I will say that the temperatures during that 14-day period, the maximum air temperature was only 30 degrees Celsius. So we wouldn't have expected there to be sunburn pressure, but I'll kind of go through some of the data. And so here you can see this is the amount of fruit within the tree belonging to, with varying red color coverage. So as you go to the right, it's going from 0% red color coverage to 100% red color. And you can see with no retraction, that curve is relatively flat and to the left. So there's a greater proportion of fruit that has poor color development. And really anything less than 40% markets out at a lower price. So it is a bicolor variety, and I think the minimum requirements are somewhere around 33% for a high-class apple. So getting rid of any fruit below 33% color has big economic benefits. So by retracting the nets both 7 days and 14 days before harvest, we're able to increase red color. And knowing that we can go 7 days before harvest gives us better confidence in the weather forecast. So we know that we look at the weather forecast 7 days before harvest. We know that that weather looks like it's going to be relatively good in terms of sunburn risk, so we can open it up. So the closer you can go to harvest and still have that red color benefit is really important. And then this is one thing that surprised us. Because the days were only 30 degrees Celsius, we were expecting that there wouldn't be any really risk of sunburn happening. What we see is that even under those conditions, by retracting, we're increasing the amount of losses to sunburn. It's not a large amount. It's only about 4% that would be fruit that would be downgraded because of it, but it is a trade-off between that red color and sunburn in varieties that are earlier in the season. So it's really just something to be aware of. I think there's probably some uncertainties around the sunburn model and thresholds that we just don't quite understand yet. Another big benefit of nets is improving canopy infill. So the trees grow better under nets, and we see about a 25% increase in growth underneath nets, not just in shoot extension, but the amount of branches and shoots underneath nets. It's just a less stressful environment. So so we talk about providing nets or putting nets up or putting the structure to be able to put nets once they come into production. But if you're going to have trouble filling your space, you're almost better putting that net up earlier and getting stronger trees as early as possible because you're going to fill your space faster. And then just kind of go through some of the different designs we're using in Washington. So just that traditional over-the-top structure, you can see reflective extende being used in a lot of the blocks in Washington. It's very, very common, both netted and non-netted, to use reflective material. Some growers, whether they're growing organically or they're managing wind, they're using exclusion nets. So it eliminates codling moth coming in and out of their orchard. So some growers are using that for when they grow organically to be able to control codling moth. We get this Louvre system, which is a system where it is completely open, or the tree is exposed during the morning when it's photosynthesizing and there's no or low sunburn pressure, and then during the afternoon it's shaded, so then it provides protection against that sun late in the afternoon when sunburn pressure is high. And then of course we're using drape netting as well. I think it was more commonly used 2 to 3 years ago. We have problems with the durability of the material, and the workers struggle to work underneath nets. You have to roll it up, or you have to climb in underneath it to do things in the orchard. So it's more challenging to work with and less durable than some of the over-the-top structures, but it is cheaper. It is a cheap option, especially if you're trying to retrofit. You have an existing block that you want to drape. That's a good option. So just kind of summarize some of the work we've been doing on netting. So we see improved sizing and quality. We see reduced water use, increased canopy infill, which is important for that early establishment phase of your orchard. We see there's reductions in sunburn, and we see hail protection, which isn't a big deal for us, but it does happen, and any additional benefit of that hail protection matters. Some of the issues, and we're still trying to address them, is the labor to deploy and retract. So working with those new retractable net systems, they're incredibly labor efficient to move in and out. They're very quick. You do them from the ground. You don't have to rent lifts. We have problems with having enough lifts available in the springtime to do the deployment and then the retraction in the fall. The color development, which we're developing strategies to improve that, and then it really just comes down to cost. But when you stack the benefits of reduced sunburn, being able to control water, specifically for us, for Honeycrisp, I know it's not a variety you grow, but there's economic benefits to being able to control water, to control vigor and optimize fruit quality. Envy will be a variety that would have a benefit on. And the benefits really do outweigh the cost. It doesn't take long to pay for netting. When you're getting the hail protection, you're getting the sunburn protection, you're getting the better fruit quality and the better sizing. And then just lastly, in the last couple of minutes before lunch, I know we're getting a little long in time, but I just wanted to show a project we've been doing the last year on trying to understand how sustainable netting will be in the future in terms of being able to control sunburn as temperatures increase. So we saw a lot of pressure last year where temperatures reached 48 degrees Celsius, and when temperatures reach that, it doesn't matter whether you have net or not because it doesn't cool the air temperature, and it only reduces the incoming radiation by 20%, so sunburn pressures are high. You'll still get high sunburn because of those temperatures. So the more those temperatures happen, the greater the more at risk and the less viable netting will be. So historical risk, this is a whole map of the U.S., different apple growing areas. Washington State is really one of the few regions where sunburn risk is historically present. We don't really get much in the Northeast. We don't get much in the Midwest. Sunburn is really not a consideration, but it is starting to be. And when you look at projected changes of amount of sunburn days per year, so historically we get between 1 and 10 days of sunburn pressure a year. It only takes 2 hours to get sunburn on a fruit, so even 1 day matters, but in terms of being able to manage it, 10 days is a whole lot easier to manage than 20 to 30 days. So when you look at projected changes for Honeycrisp, which is very susceptible to sunburn, and you have no nets, you get sunburn pressure primarily in the southern part of the state, historically moving to extensively throughout the state and for over a month a year of historical pressure. When you apply netting, you see a change where there's still not, or historically there's by using netting, we're able to control sunburn. There's really not a lot of sunburn pressure. But going into the future, netting alone won't be enough. And we saw that last year where just netting was not enough to control sunburn when it's 47 or 48 degrees Celsius in Honeycrisp. Crisp Pink, we don't have, actually we have areas where Crisp Pink is grown that does not have netting and does not use evaporative cooling. They just use protective sprays and it works quite well. But looking into the future, we see that shift where growers may have to start using netting on Crisp Pink. And we see that there. So netting and then no netting, where you can see the pressure's a little bit higher. So with that, I'd just like to, my lab group has done a lot of this work. Different people have come in the lab throughout the years, and collaborators from both Washington State and beyond, and the industry for supporting and funding my work. Thank you.